am Vaibhav and welcome to the channel Vaibhav E-Learning Academy. Today we are going to start a new topic in physics, that is refraction through a plane mirror. So we'll be discussing first what is refraction, then why does refraction happen, and third one, how does it happen. So these three questions we have to answer. So let us start with the topic refraction. So as we all know, the speed of light so in air it is 3 into 10 power 8 meter per second. So in 1 second 3 into 10 power 8 meters a light can cover in air. This is very important. Air or vacuum. In air or vacuum, the speed of light is 3 into 10 power 8 meter per second. Now, if we take in water, the speed of light is 2.25 into 10 power 8 meter per second. This is in water. Then, in glass, it is 2 into 10 power 8 meter per second. So here we can see that the velocity of the light is not constant. Velocity or speed of the light is not constant. Here the speed of the light in air or vacuum is 3 into 10 power 8 meter per second. In water it is 2.25 into 10 power 8 meter per second, and in glass it is 2 into 10 power 8 meter per second. So here can you notice the difference in the speed of the light? So here it is 3 into 10 power 8, 2.25 and 2. So as the matter is getting denser, the velocity of light is slowing down. So as you see the air, is the air optically denser or rarer? What is optically denser? I'll explain you in a moment. So air is very light. After that we have water, which is kind of like more heavy than air but less than glass, and then we have the glass, which is more denser. So here we can see if the density of an optical density of an object is more, the speed of the light is less. Air it was very less, the speed is more. If the density of water is more, then the speed of the light is low as compared to the air, and in glass it is more slow. So now we will discuss what is optically denser and optically rarer medium. To understand refraction, these terms are very important. So over here, refraction just basically means bending of light. Refraction means bending of light. So if the light is going from one medium to another medium, so let us take over here. This is air, this medium is glass. If a light, let us take a ray of light over here like this. It is going from one medium to another medium. We have to draw perpendicular, which is the normal, and if it bends towards the normal, then this is called optically denser medium. So if a ray of light, this is its original path, it has to go like this, but over here it is like refracting. Refracting means bending of light. Here the light is bending, it is bending, right? So this is called refraction. So if from one medium to another medium, the ray of light is bending towards the normal. Now what is normal? The normal is the perpendicular drawn towards the surface. We learn about these terms like incidence, refraction and reflection. Not refraction, reflection. We learn in some other concept, that is reflection of light. So here, if from one medium to another medium, the ray of light is bending towards the normal, then the other medium is said to be optically denser medium. And similarly, for example, this same scenario over here, like this, normal bending towards the normal, and then again we are drawing a perpendicular, and then this time it is going away from the normal. Now what is this? So here it is still air, it is still glass. So if going from, and here this side also it is A only. So from one medium to another, if it is bending towards the normal, it is called optically denser medium. Now it is hitting the surface of the glass once again. So we draw one more perpendicular and we see that the ray of light is going away from the normal. So this is called optically rarer medium. So over here, if you take the example of air and glass, glass is optically denser medium and air is optically rarer medium. So here one more point to note, optically denser medium. It does not mean that the density factor. Here density is equal to optically denser. It is not equal to optically dense. So density is not equal to optically dense. For example, if you take example of a turpentine oil. Turpentine oil, if you take water and turpentine oil, if you pour the oil on the water, the oil floats on the water because the density of oil is less than the density of water. But here the density of the oil is more than the water in optically denser medium. If you take the optical density, the oil is more denser, but if you take density, then the water is more denser. So here density is not equal to optical density. Okay. So optically denser medium. So optically denser medium, if the light is going through a medium and the light turns towards the normal, bends towards the normal, that is called optically denser medium. And if light is traveling from one medium to another medium and the light goes away from the normal, that is called optically rarer medium. So this is the concept of optically denser medium and optically rarer medium. So now, by now you must have understood how refraction occurs. So why does refraction occur and how does refraction occur? First question, what is refraction? We understood. The bending of light. I'll write the definition. The bending of a ray of light when it passes from one medium to another medium is called refraction. So the bending of a ray of light when it passes from one medium to another medium is called refraction. This is the basic concept that what is refraction. Second question, how does refraction happen? So to understand how does refraction happen, we need to draw some diagrams. So some diagrams. So let us take one surface over here. So this is one boundary which is separating two mediums. Let us take one is air and one is water. Air and water, this boundary is separating. Now one ray of light is hitting like this. It gets reflected. And here we draw the normal. This is the angle of incidence, this is the angle of reflection. Now some part of the some part of the ray of light gets reflected, but some also get refracted. Now here we have air and water. Which is more optically denser? More optically denser over here is water. So it will bend towards the normal. So the light bends like this. So this is called the angle of refraction, R dash. So here R is the angle of reflection and R dash is the angle of refraction. But here mostly just because of this diagram, R and R dash are different. But from now onwards in the diagram we will not represent this reflected ray because the concept is about refraction. So one ray of light is coming from any medium and it is like hitting the boundary. Some part of it, out of 100%, if it is water, see, because of the plane mirror, if there is a plane mirror, then only 100% reflection takes place. But here, only 4%, 4 to 5% of the light is being reflected, gets refracted. So over here it is water. So 95 to 96% of the ray is being refracted and only 4 to 5% of the ray is being reflected. So this is the concept of refraction. So let us take here, this is air, this is water. Here we can say that this is rarer medium and this is denser medium. Rarer in the sense like optically rarer and optically denser. So over here we have air and water. A ray of light is coming over here, making an angle of incidence. 4 to 5% is being reflected back, and 95 to 96% of the light is being refracted. That is, it is bending towards the normal. So this is called refraction. So if we take one more scenario over here, let us take one more scene. So here, now this time this is glass, this is water. Let us reverse it. Here we have glass, here we have water. Glass and water. So now again one ray of light coming like this. Now we draw one normal over here. So as this is water, I'll make some things like this. So here 4 to 5% of the light gets reflected, no need to write that. Now here glass, here it is water. So tell me which one is optically rarer. Optically rarer, in this case it is water. Optically rarer medium. And this is optically denser. So now here one ray of light is coming from optically denser medium and going to optically rarer medium. How does it turn? It refracts as going away from the normal, not towards the normal, going away from the normal like this. So this was supposed to be reflection and this was supposed to be the actual path. But instead of this, it goes over here. So this is called angle of deviation delta. This delta over here is angle of deviation. About this angle of deviation, we will learn more in prism concept. In this chapter only, but in prism concept. So this is the second scenario where the light is coming from denser medium to rarer medium, and the first one was from rarer medium to denser medium. So here one more question has been answered. How does the light refract? So it refracts like this over here. And why does the refraction takes place? Because the air is going from one medium to another medium. So now we will be discussing about the laws of refraction. So let us see what are the laws of refraction. So there are mainly two laws of refraction. Laws of refraction. What are laws of refraction? So the first law, which is very easy, that the incident ray, refracted ray and the normal lie on the same plane at a same point. So the incident ray, refracted ray and the normal all lie in the same plane of the same point. So the second one is actually a little bit important over here. The second one is Snell's law. What does this Snell's law say? Here Snell's law is sin I by sin R is equals to constant. Here sin I and sin R is equal to constant. So what is Snell's law? The ratio of the sine of the incident ray and the refracted ray is always a constant. So the ratio of sine of incident ray, so sine of incident ray, sine of refracted ray is always constant. This is the main Snell's law, but usually in this concept we will be using one formula, that is mu1 sine I is equals to mu2 sine R. So over here, how does this relation come? There is one topic which is called with respect to, like finding the refraction with respect to. So what is mu over here? Mu is called the refractive index. Refractive index. Now what is refractive index? Refractive index is nothing. It is like just not even a unit. Refractive index is like a comparison, like ratio. Ratio in the sense you are comparing two quantities over here. So mu, which is the refractive index, it is pronounced as mu. So this symbol we use for getting a refractive index. So one medium and other medium, each medium has one refractive index. The more the refractive index, the less the velocity of light, and the more the refractive index, the more optical denser. So let me write that down. Here mu is equal to refractive index. Refractive index. So over here mu is refractive index. The mu, if the mu is greater, then the velocity of light in the medium is low. If mu is greater, then the density, optical density, is more. So this mu is just one term which is used to specify. So mu is separate for mediums except vacuum and air. So it is for a medium. So the mu over here, if the mu is more, in the sense, let us take one example. You are going on a road. If there is more traffic, that is, if there is more mu, it will take slow time for you to cross the road. But if there is low traffic, that is a low mu, then you can cross the road easily. So that is one point over here. And then if more the mu, the optical density is more. So this is one physical term. So here, for example, this is one medium and this is another medium. Let us take this has a mu of 1.2 and this has 1.5. Now here, which one is more denser? This one is more denser. Which one is rarer? This one is rarer. So more dense and this is rarer. So this is what mu, what is the meaning of mu? So over here. So how can you find mu? So finding mu, it means how can you find refractive index? Finding refractive index is one very important topic. Here we use the formula mu is equals to C by V. Mu is the refractive index. Refractive index. C is the speed of light in air. V is the speed of light in the particular medium. So here, if you want to find mu, then you need first C, that is speed of light in air. It is always constant, 3 into 10 power 8 meter per second. V, speed of light in the particular medium. So to explain this, I am going to take one example. In the starting of the video, I said that the speed of light in air, it is 3 into 10 power 8 meter per second, and in glass, instead of glass, just take water, it is 2 into 10 power 8 meter per second. Now, how to find the refractive index of water? So here, if you want to find the refractive index of water, we take like this: mu water, W is equals to C. C is the velocity or speed of the light in air. It is 3 into 10 power 8 meter per second by V is the velocity of light in that particular medium. Here, what is the particular medium? It is water. So in water, it is 2 into 10 power 8 meter per second. Meter per second cancel. 10 power 8 cancel. 3 by 2. 2 ones are 2 1.5. 2 ones are 2 1 balance and then 0 1.5. So mu of water is equals to 1.5. So this, as I said, it has no unit. See, meter per second and meter per second is cancelled. Here we are using mu just to find out the refractive index. Like in comparison to another medium, is this medium optically denser or rarer? That is explained by this mu, that is refractive index. Let us take refractive index of air over here. Instead of W, air. So speed of light, C is equal to speed of light in air. It is 3 into 10 power 8 meter per second. And in that particular medium, it is same air. So we can take 3 into 10 power 8 meter per second. So here both the terms get cancelled, 1. So refractive index of air is equals to 1. Similarly, refractive index of vacuum is equals to 1. Refractive index of water just we found 1.5. So like this. So now we'll be discussing one more concept, that is shift, and we'll be discussing one more concept, that is taking mu with respect to two quantities. Let us see. Discussing about the mu of comparison. So let us take one example over here. We have mu 2 with respect to 1. So what is this? Mu 2 1. So here you have to take mu, which is the refractive index of the second medium with respect to first medium. So second with respect to first, then first will be coming first. So mu 1 by mu 2. You can similarly represent it as mu is equals to C by V. Here also C by V. So similarly you can just represent that if you are taking with respect to two mediums, so it will be mu 1 by mu 2. Now here mu 1 by mu 2. Now we have mu 1 and mu 2. So C is always constant, right? Speed of the light in air, it is always constant. Here we can take one value V1 and we can take one value V2. Here if we are taking 2 with respect to 1, then this will be mu 2, this will be mu 1. So mu 2 with respect to 1. What is the first quantity over here? 2 with respect to 1. So 2 by 1, which is equals to C by V1 by C by V2. C and C gets cancelled because C is equals to 3 into 10 power 8. It will be always. So we can say that mu 2 by mu 1 is equals to V2 by V1 by V2. V1 by V2. This is one very important formula. What is mu 2 over here? Mu 2 is the refractive index of light in the second medium. Mu 1 is the refractive index of light in the first medium. V1 is the velocity of light in the first medium and V2 is the velocity of light in the second medium. So I guess that is it for today's video. Today's video was a little short one. In the next video, we will be discussing about many different topics. First topic is shift through a glass slab. Then we will be discussing about critical angle and then total internal reflection. Then lateral displacement, and then we will discuss about prisms, and the chapter will be over. So I hope you have enjoyed today's video. Do like this video if you enjoyed it. Subscribe to this channel if you are new to this channel. Press the bell icon. See you next time in the next video. Thank you and goodbye.